everyone, welcome back to my YouTube channel. In this video lecture we are going to see working principle of operational amplifier, in that open loop operation, closed loop operation, inverting amplifier operation of the operational amplifier, and non-inverting configuration or non-inverting operation of operational amplifier. So in closed loop operation, open loop operation, what we have seen that inverting and non-inverting terminal V1 and V2, they are not connected to V out, means there is no feedback from V out to V1 or V out to V2. That's why we are considering it to be as open loop operation. So we have differential input V1 and V2, we have single ended output, and we have a formula of V out is equal to AOL inside bracket V1 minus V2. So AOL is called open loop gain, and we have seen that the open loop gain is practically, we can say ideally it is infinite, but practically of some value from 20,000 to 200,000. So what we have seen is that if AOL is infinity, so what we'll get? We'll get V out is equal to plus infinity and V out is equal to minus infinity. But in case practically if we use a power supply of plus VCC and minus VCC, if we use 12 volt power supply, so that will not get plus infinity, will get plus V saturation, and that is approximately equal to 11 volt, not 12 volt. And in case of minus infinity, it is to be minus V saturated and it is to be minus 11 volt. Okay, so plus 11 volt for plus V saturation and minus 11 volt for minus V saturation. So why 11, why not 12? Because at least one voltage required for the operational amplifier, inside that the transistors are there, so to run some applications in there. Now in case of 741, we'll have a gain of 2 into 10 raised to 5, the practical gain. So V1 is the voltage at the inverting, non-inverting, and V2 is the voltage at inverting. So we'll have V1 minus V2. Look at here, V1 is at non-inverting, V2 as inverting. So it is clear from this above equation that the output will be non-zero, right? If and only if the differential input voltage is non-zero. Means V1 and V2, if the difference is non-zero, output will be non-zero. So if it is to be 0, V1 and V2 should be equal. So in ideal condition, or we can say practically, there are small imbalances in the op amp. So that's why we are getting very small applied differential input leads to very large value. So a very small differential input that will leads to very large, but this very large volt that will not go beyond the supply voltage. So hence it is not violating the law of conservation of energy. Means we can use operational amplifier in open loop, but the output of that operational amplifier will be not infinity, it will be plus V saturated or it will be minus V saturated. Open loop operation can be used in some sockets, in few sockets, but most of the cases we are going to use the comparison between the open loop and closed loop is that most of the time we are using a closed loop operation. So what is a closed loop operation? So closed loop operation is there where we are having feedback. So feedback from what? So part of output signal feedback to the input. This is called as a closed loop operation. So from where we are going to get a feedback? Suppose inverting and non-inverting terminals are there and we are having a V out. So we can have the input where the feedback is given two signal that will be simultaneously present. Means one of them will be original input signal. So look at inverting amplifier. If we fed input to the inverting amplifier, the original signal will be the input, and the feedback signal from V out, that will be the other signal. So that's why we are having two signal, and that may be in phase or may be out of phase. So the original applied signal and the feedback signal are in phase with each other, then it is called as positive feedback or regenerative feedback. And if the applied signal and feedback, they are out of phase with each other, then it is called to be as a negative feedback. Output is connected to inverting of the operational amplifier, means the signal is out of phase with each other. So that is called. And in case if we connect the output that is to the non-inverting terminal, then we can say it is in a phase with each other. That's why it is considered to be as positive feedback or regenerative feedback. So regenerative feedback, it will produce oscillations. So if the positive feedback is there, it will always produce the oscillations. While in case of negative feedback, it will not going to give us the oscillations. It will reduce the gain of the circuit. So each type of feedback, negative or positive, it has its own advantage and own disadvantage. So look at the gain. So in case of this, the VO, that is the output voltage, it is equal to ACL into VD. So ACL is a closed loop gain. VD is the differential voltage, that is equal to V1 minus V2. So V1 as non-inverting, V2 at inverting. ACL, that is a closed loop gain, that will be reduced in case of closed loop operation. So how it will be, we are going to see it. But kept in mind, when feedback is positive, we'll get oscillations, and feedback is negative, we can have gain stabilization. Gain stabilization means gain will be not equal to infinity, it will have some very small value. So this is the way the feedback can be connected. Look at here, the circuit V out is connected to inverting input terminal of the operational amplifier. So it will not going to produce oscillation, it will produce stabilization, gain stabilization. So look at here, Vi is the input, the resistance R1 and resistance RF are there, RF in feedback, while R1 at the input terminal. So this is the way the inverting amplifier is. So look at here, the V1 and V2 according to virtual earth concept, V1 and V2, they are both at same potential, so we can say it is equal to 0. So how to find out the gain of this inverting amplifier? So we have to do it mathematically. So for that purpose, you should know that the virtual earth concept, where V1 and V2 both are equal to 0 and the Zin is infinity, I1 current flowing through the inverting and non-inverting terminal I2, they both are equal to 0. So you can see here, this is the circuit of the inverting amplifier. The op amp that will produce output, that will be out of phase with respect to the input. So we are going to prove it by using mathematical calculation, how it is out of phase with the inverting amplifier. So when input pulse is positive, the output will be negative, or if the input pulse having a 0 degree, output pulse will be having a 180 degree. So look at here, this is the mathematical calculations, how we are going to find out the gain of the inverting amplifier. So look at here, gain formula is there, AV is equal to V out upon V in, where the Vi is equal to II into Ri. So how it will be, it is given in here. So Vi is the current, that is Vi is the voltage that is flowing through resistance R1, we can consider it to be as Ri. So that's why V1 is at 0. So we can say that from V1 to Vi to V1, we'll have Vi is equal to I into Ri plus V1. V1 is equal to 0. So that's why the Vi is equal to I into Ri. So this is due to the virtual earth concept. The Vi we are getting is equal to I into Ri. So that's why the final Vi will be equal to I into Ri. Then we have to find out the next term, that is equal to V out. So how to find out the V out? V out finding is very easy. So the current that is flowing from V out towards the V1, it is at virtual earth concept, that is equal to IF. So the current that is flowing through RF is considered to be as the voltage difference across the RF will be IF into RF, and again there will be plus V1, but V1 is at 0, so we can say V0 is equal to IF into RF. So it is considered that I1 and I2 both are equal to 0, current entering to the inverting and non-inverting terminal as 0. So we can see here, according to Kirchhoff's current law at junction V1, so current entering to the node is equal to current leaving the node. So current entering to the node are II, and current entering to the node are IF, and current entering going outside the node is I1. So we can say that the II plus IF is equal to I1, but I1 is equal to 0. So II plus IF is equal to 0 will be the equation. And finally, what we'll have, II is equal to minus IF. So look at here, II plus IF is equal to I1, but I1 is 0. So II plus IF is equal to 0. So that's why II is equal to minus IF. So in first equation, what we are having, II into Ri, and the second equation we are having V0 is equal to IF into RF. At that time, II is equal to minus IF. So substituting the values of V1, or we can say Vi, and If in equation V out. So V out is equal to If into Rf. So now that If, it is considered to be as minus Ii, and minus Ii is nothing but Vi upon Ri. So what will have, what will have, what will have, that V out, Vo is equal to minus Vi upon Ri into Rf. So why there is a minus sign? So minus sign, it is due to Ii is equal to minus If, and if we find out the value of If, that If value will be equal to Vi upon Ri, and due to that If, the minus Ii, so that is equal to minus Vi upon Ri. So we can have the value of If in here, that is equal to minus Vi upon Ri. So we'll have V out is equal to minus Vi upon Ri into Rf. So if we take the Vi at the other side, V out upon Vi, that is nothing but our gain Av, that is equal to minus Rf upon Ri. This is the way the inverting amplifier gain is calculated. So kept in mind the formula of it, minus Rf upon Ri, where Rf is the feedback and Ri is the input resistance. So this will decide the gain of the inverting amplifier. So look at the problem. If we have the following circuit where the open loop gain is 100,000, the gain we have to find with the circuit where R1 is equal to 1 kilo ohm and Rf is equal to 49 kilo ohm. So gain of the gain formula for this inverting amplifier is to be minus Rf upon Ri, that is equal to minus 49 upon 1 kilo ohm. So kilo ohm get cancelled. We'll get the value of Av is equal to minus 49. Then the second example where the value of input resistor is 10 kilo ohm and the feedback resistor is 100 kilo ohm, where we have to find the gain of the inverting amplifier. So you should know that the given quantities are Rf is equal to 100 kilo ohm and Ri is equal to 10 kilo ohm. The gain formula is Av is equal to minus Rf upon Ri equal to 100 kilo ohm divided by 10 kilo ohm. So if we cancel out 10 and that equal to minus 10. Av, the voltage gain is equal to minus 10. Non-inverting amplifier, look at here, the input is connected, output is connected to the uh, inverting input and input is connected to non-inverting. So Vn is connected to non-inverting terminal and the output is connected to inverting. So gain stabilization there is no, we can say, oscillations due to the positive feedback. We have a negative feedback only. So look at here, there is a feedback resistor Rf that is connected in between V out and V1, and there is a resistance R2 that is connected directly to the ground called as 0. So what will happen in this configuration? We are applied signal at input, that is called Vin, that is to non-inverting terminal. So the input terminal, the output gain of the operational amplifier becomes positive. Why it becomes positive? Because the input is connected to non-inverting terminal, so that's why the output will be positive. Means the output signal and input signal will be in phase with each other. So in case of this non-inverting amplifier, the gain will be decided by Rf and R2 voltage divider network. We are going to see how to calculate the gain of this non-inverting amplifier, where the Rf is a feedback resistor and R2 is the other resistor connected from V1 to ground. So according to this, we know that the Zin is infinity and no current that is flowing through the inverting and non-inverting terminal. So according to virtual orth concept, the V1 is considered to be as Vin. Now we'll calculate the gain of the non-inverting amplifier. So you can see here the arrangement is look like this. So where the resistance Rf that is connected from V out towards the inverting terminal and non-inverting terminal is connected to Vin. So we can say that V1 is nothing but Vin. So this is a non-inverting configuration and R2 is connected from V1 towards the ground. So you can see from this we can calculate the closed loop gain, that is called ACL or AV. We have to calculate first of all the V1 across the resistance R2 according to voltage divider network or potential divider network. So you can see here the V1 is considered to be as R2, where we are measuring across it, divided by R2 plus Rf total resistance into V out is the source. So at, we can say, virtual earth concept, or we can say ideally the V in that is equal to V1. So V1 is equal to V in. So now we are having V in, we are having V out. So if we take V out upon V in, we'll get the gains formula. So calculation of voltage gain AV is equal to V out divided by V in. So if we take V out and if we put the value of V1 as V in, we will have V out upon V in is equal to R2 plus RF divided by R2. So in this case, we'll get R2 divided by R2 plus RF divided by R2 is equal to 1 plus RF divided by R2. So R2 will get cancels each other. We'll get finally 1 plus RF divided by R2. So while considering this, the R2 divided by R2 plus RF, it is considered to be as beta. And we can see here R2 plus RF divided by R2 is A. So A is equal to 1 upon beta. So beta is the feedback fraction over here. So if suppose feedback fraction to be calculated, it should be 1 upon A, or if A to be calculated, it should be 1 upon beta. We can find out in the problems. So look at here, non-inverting amplifier problem. So where open loop gain is 100,000. So open loop gain, it is not matters in this problem because we are talking about the closed loop circuit. So the feedback fraction we have to calculate beta, it is equal to 1 upon A, or it is to be equal to R2 divided by R2 plus RF. And the gain we have to calculate it, R2 is 470 and RF is 5.1. So you can see here the beta is equal to R2 divided by R2 plus RF, and we can have A is equal to R2 plus RF divided by R2 or 1 plus RF divided by R2. Kept in mind the formulas of it. So the beta that is to be calculated as R2 is equal to 470 divided by 470 ohm plus 5.1 kilo ohms. So 5.1 kilo ohms we have to consider it to be in ohms. So 470 divided by 470 plus 5100, right? 5100. Then we can add them together. 470 divided by 5570, right? 5570. 470 divided by 5570 is equal to, you can find out from the calculator, 0.084. So this is the beta. So we can take A is equal to 1 upon beta. So 1 upon 0.084 is approximately equal to 11. Okay, so this is the way we can calculate, or we can put the value of 1 plus RF upon R2. 1 plus RF is 5.1 kilo ohm and the R2 is 470. So if we put the value of 1 plus 5.1 is considered to be as 5100 divided by 470. So you will get approximately equal to 11.90. Okay, so calculations of A and beta, you can do it. So this is the way to calculate gain and feedback fraction.